recently there's been a few questions regarding how to use the t-table and the chi-squared table, when to use which one, how do you get the values. So let me just kind of review that. The table that hopefully, the easiest way to do that is with a table. You could use a computer, you could use Stata, you could use R. It's not as easy to use the TI. Sometimes you have to add programs to it. You know, you can add user-written programs. I have some programs in my office that you could add to do it, but I think it's the easiest way to get the values, like the t-values or z-values or chi-squared values for your confidence intervals. The easiest way to do that is via one of the tables. Like, hopefully you guys have one. If not, they're in Moodle. So remember, the way this works, the big decision is when you use t or chi-squared or z. All that comes down to is what type of confidence interval are you doing. Right? So when you look at the formula and you say, oh, okay, I'm doing a t interval for mu. Well, then that's when you use your t-table, right? So if you're doing a z interval, that's when it's a little bit tricky, right? When you're doing a z interval, you're still going to use the t-table, but you're going to go down to what? The infinite degrees of freedom. So something that you can, if it helps you to write this on here, you know, just go ahead and say, this row here for infinity are the z values. If it helps you to write that on there, go for it. Anything that's going to help you kind of recall what to do. You know, like we've been using 1.96. That's right here for 95%. So if it's a z interval you're doing, use the t-table, but go down to infinite degrees of freedom. If you're doing a t confidence interval, you know, just make sure you pick the right row. Something else sometimes people ask about is, well, what does this area to the right thing mean? Well, basically what that means is, if you think about this t density, what's going on here? This is our t density that's centered at 0, right? If you're doing a 95% confidence interval, you want the values that capture the middle 95%, right? So if you're doing 95%, you're going to have 0.95 in the middle, which means by symmetry you have 0.025 here, and you have 0.025 here. This thing up here that says area to the right, if you're doing 95% confidence, notice that that's 0.025. That just says you're getting this value right here, and how much area is there to the right of it. And of course that's going to vary depending on the degrees of freedom. But the reason it says area to the right is because next unit we're going to kind of take a different approach, and we might be interested more so in the area to the right kind of information that's being relayed there. Does that make sense? So when it says area to the right, that just corresponds to this. So if you're doing 90%, you're going to have 0.05 to the right. If you're doing an 80% interval, you'll have 0.1 to the right, etc. Carl?
Does that still apply to the z intervals at the bottom?
Yeah. Yeah.
Because on the z table it goes to the left, right?
No. Well, the z table that you guys have from last unit gives you the area to the left. But that's not what this is doing. It still says, you know, when you're doing 95% confidence interval, to get this value here, you're still going to have 0.025 to the right. It's still going to look like this picture here.
Okay.
Yeah. And so this table is much more useful for confidence intervals than the z table you guys had last unit. That's why I suggest, if you're doing a z interval, you could go back and use that z table you guys had last time, but I would suggest to use this row on your t-table, because that's what this is set up to do, is give you the values for your confidence intervals. When you're doing the chi-squared, remember the chi-squared density is not symmetric about 0, like the z and the t, right? It looks something like that. And so if you're doing a 95% confidence interval, you might have the quote-unquote middle 95%. And you'd want to get this value and this value. Remember, they're going to be different because it's not symmetric about 0. So that's why there's 2 columns for 80%, 2 columns for 90%, 2 columns for 95, 98, 99, respectively. Right? So if you're doing a chi-squared procedure, like you're doing the chi-squared interval for standard deviation, say, when you're doing that one, you're going to have 2 different values. So let's say we're doing 95%. Notice there's a 95% here, there's a 95% here. You could also take the perspective of looking area to the right. So when you're doing a 95% interval, when you get this value here, how much area is to the left of this value? 0.025, right? Correct. How much, if there's 0.025 to the left, how much is to the right? 0.975. So that's why this one says 0.975 and this one says 0.025. Because it's just saying, do you want this one or do you want this one? If you do 80%, if there's 80% in the middle, that means you're going to have 10% here, 10% here, right? Well, for this value, if there's 10% to the left of it, there's 90% to the right of it. And if there's here, there's 10% to the right of it. So that's what that other row is giving you. For what we're doing now, this area to the right is not that useful, but when we do hypothesis tests next unit, that's something that will become useful. Okay? And again, just pick the correct degrees of freedom. For both of the procedures that we've been doing so far, the degrees of freedom is n-1. That's not always the case, though. Degrees of freedom is going to be related to the sample size, but it might be related in a different way for different things. Are there any questions about how to use the table? Does it make more sense now, hopefully?